both of them. We'll see how that goes. Cool. So I think we'll go ahead and get started here in a second. I don't know when they're closing the door up. Can you guys hear me now? All right. Are you good to go? Cool. So this is a year in the Empire. I always like to ask this. How many people use Empire? Oh, that's a lot more than I thought. That's awesome. So first things first, this project would not be possible if it wasn't for the help and phenomenal work of a large number of people. You know, we kind of built the weaponized component of this, but huge amounts of the back end were created by a lot of other people, and we drew on a lot of existing work. So Powersploit by Matt Graber, Chris Campbell and Joseph Bialik, PoshSecMod by Carlos Perez, they're both sitting here in the front row. Unmanaged PowerShell by Lee Christensen Tifkin, who's also somewhere over here in the second row. Mimikatz by Benjamin Delpy and Vincent Latoy. And everyone who's contributing modules, bugs, fixes, and their time to help this project, we've been overwhelmed by the community participation. It's been awesome. Oh. Cool. So, my name is Will Schroeder. My handle is Harmjoy. I am a security researcher and red teamer at the Adaptive Threat Division of Verus Group. I am the co-founder of the PowerShell Empire and Python Empire project, both of which we'll talk about. I created PowerUp, PowerView, a couple like offensive PowerShell tool sets that are kind of separate packages. I was one of the primary creators of the Veil framework. I'm now currently a Powersploit developer with Matt. I also helped out with the Bloodhound Active Directory Control Flow Path project that was presented at DEF CON about a month ago. And I was recently this year got Microsoft PowerShell MVP, so I'm quite happy that Microsoft is willing to recognize offensive PowerShell professionals in the MVP status. It's pretty great.
All right, can you hear me all right?
Yep.
Awesome. All right, I'm Matt Nelson. My Twitter handle there is Enigma0x3. I am a red teamer and security researcher. After working with Will and Matt Graber, I can't even call myself a security researcher. So I'm primarily a red teamer for Verus Group's Adaptive Threat Division. I was a former sysadmin. I've only been out of college for about a year, so I worked full-time as a system administrator while I was in college, and then moved to Virginia to work for Verus, and loved every single minute of it. So...
All right. This is Matt's first time speaking here, so drink up.
Oh, you have to do both?
Preferably both of them.
That's disgusting. Goodness.
You're not gonna do the other one?
I'm not going to be able to speak clearly if I drink that one, so.
This is also gonna be disgusting. You can keep talking.
No. All attention on you. Go ahead.
Go keep talking.
All right, so a short version of what this presentation is going to be about. It's kind of a that face. That's horrifying. You good?
Yeah, I'm good.
All right. I think we'll be okay. So Empire. Empire's been out for not too long. It's made a lot of improvements over the last year or so. We're going to be releasing 2.0 today. It's very beta, so be gentle with the code, more or less. And we're going to kind of...
Oh my god, you just iced us.
We literally just...
Are you iced already?
No, Draper just iced us.
Don't make us do two.
Come on.
I'm sorry. It's the rules. It's the rules. Come on, it's the rules. I'm sorry.
Oh, God. Does anyone have an opener? Oh, there we go.
This one's much warmer than the other one.
True chance. I really am going to vomit. Actually, I'm about to vomit, so I cannot finish that. I'm sorry. All right.
I haven't done that since college. So 6 months ago.
All right.
Perfect.
All right.
All right.
Let's go.
Keep it going. So we're gonna kind of cover some of the motivations for the 2.0 release and some of the integrations. So as some of you might know, there's Python Empire, which is also released at later on. We'll talk about this later. So kind of go over some of the motivations behind that, and then kind of the merge of the two. Then we're going to go into some demos. Did I break it? Oh, okay. Perfect. All right, so Empire. I'm sure a lot of you, as I saw with all the hands, everybody's pretty familiar with Empire. It's a full-featured PowerShell exploitation framework, and then with the Python Empire, it's the same deal with Python. The core agent was initially built in PowerShell, the agent itself on targets running as PowerShell, and the controller itself was built in Python. It uses a backend SQLite database, all that good stuff. A lot of you are familiar with it, and so it's kind of bounce up.
And like one of the big points with the project was to have a really big UI focus. So we really like to care about tag completion, having a persistent credential store. We basically wanted to build the agent kind of how we operated, and we wanted to build in all the little features and things that we always really kind of wanted in our operational platform. Like, for example, you'll see in the demos like OPSEC safe checks and things like that. So we tried to put a little bit of love and like a little bit of details in a lot of the components of the UI.
So why did we build a PowerShell agent or botnet? It initially started as a thought exercise. We noticed that there were a lot of offensive PowerShell frameworks that existed. So PowerSploit, at the time Power Tools before it was emerged. So all these different really smart people were creating all these really awesome PowerShell post-exploitation tools, but they're kind of all scattered all over the place. And so it was really hard to, if you were on an engagement, you had to bring those tools down, make sure that you had the ones that you needed, make sure they were all up to date, and it was kind of a pain in the butt. And so the initial idea was to compile every offensive tool set or framework into one centralized location that you can operate with from its own custom agent. And the other primary motivating factor for the creation of it was, in our minds, defenders weren't ready for PowerShell attacks. PowerShell, people were doing all this awesome stuff with PowerShell and all this good stuff, but defenders weren't aware of it. They weren't aware of how capable an attacker can be when they're armed with it. It exists by default, and so every attacker basically had this trusted Microsoft signed binary that was at their disposal to do whatever they want. And so the goal of this framework was to kind of push that forward and say, hey, here is a fully functional open source rat that implements all this awesome PowerShell tech. Now, people are going to start using it on their pen test and red team engagements, and so defenders can start to be aware and determine how they're going to actually, detect and respond to these attacks. So, yeah, if you can think about it, or if you can imagine it, it's likely already been done. It's kind of the philosophy I like to think of. This isn't groundbreaking. PowerShell rats, I'm sure, existed long before Empire. This is just bringing it out into the light, making sure that everybody's aware of its capabilities and make sure that they understand the process for detecting or remediating.
Yeah, and so one of the differences we saw was, we've been doing offensive PowerShell components, PowerView, PowerUp, PowerSploit for years. And a lot of clients kind of knew about different components, but we really saw what we think was kind of like a change in thinking or awareness in clients after Empire was released, where all of a sudden they're like, oh, like crap, you can own my entire enterprise using literally nothing but PowerShell. Like maybe we should actually start locking this down. So people started taking it a little bit more seriously after this was released. I don't know if that's coincidental or if hopefully the project had something to do with it, so it had enough publicity, but it really, we'd like to think has done a reasonable job about raising awareness for these types of attacks.
And so the people that likely use these agents in the past aren't the people that are going to talk at security conferences. And so the goal was to, like I said earlier, bring everything into light, get it out in the public, make sure people are actually capable of detecting and responding to these types of attacks. So this is a picture within itself. Jeffrey Snover, who gave the keynote earlier,
over there.
is actually also known as the father of PowerShell. This I still like fanboy. Sorry. It's really cool to see a tweet like this. It's offensive PowerShell wasn't initially adopted pretty a lot of people didn't really accept it at first. A lot of people kind of called it a toy language and that it wasn't something that could be, you could write a full agent in or use in all of your malicious instances. And so this was a good kind of validation of people are starting to acknowledge and accept that you can do some pretty nasty stuff with PowerShell itself. And I think that the industry has gotten much better at acknowledging that this is a thing. And I think from at least the assessments I've been on recently, people are actually starting to monitor and detect and respond to PowerShell attacks pretty quickly, which is awesome. So year of development. I am so sorry for everybody that has issued requests or put in pull requests. We're two dudes in a basement on our free time on like Saturday nights maintaining this code. And so if you have a pull request open from like January of last year, I apologize. Blame me, it's my fault. So nearly 400 commits, which to us is a lot. A lot of contributors. The open source community has been really welcoming. One of our initial fears was people weren't going to actually contribute to it, or they would just use it and then poke us when things don't work, and we would have to become like full-time software developers in our free time. So everybody's done a really great job of contributing to it. We have a lot of issues. Most of them are closed, so we've had over 150 GitHub issues. That's going to reset with 2.0, and I hope we break records for more issues because it's a beta. Lots of PRs, which is amazing. And we'll kind of go over the modules later as far as what's been added and how the community is given back, all that good stuff. So this is cool. Watch Dogs 2, they're actually, people tweeted at us nonstop about this. They use Empire in the game, which is interesting. Just kind of a neat little screenshot that it's actually made its way out of the little like inner circle PowerShell community. Nobody really uses it outside of this small little group to it's being like introduced into a game. So people are starting to actually acknowledge that, it's a serious thing and it's an awesome thing to use.
All right, so Spencer at Zero Steiner. Last year, I came on stage for a couple of minutes during Ben 10's talk, and I let everybody know that there was an RCE in the PowerShell Empire control server. Literally 3 weeks ago, I got another GPG encrypted disclosure notice from Spencer with Skywalker version 2, and I was like, oh god, like not again. I've made a huge mistake. But the 1.6 release that we pushed about a week ago includes a fix for an additional file overwrite disclosure bug that can be turned into an RCE. To us, when this happened, like people were, like afraid, like, oh, are you going to be embarrassed or whatever? We're like, no, security's hard, obviously. We're pretty crappy developers in a lot of ways. We were really happy that somebody spent enough time to dive into the code to actually find some of these fundamental issues. So we're actually going to be writing up a blog post in the next few weeks that kind of details how we failed, how we tried to fix it, and our goal is to be as transparent as possible. We got a fix out within 24 hours and patched it. So in the 1.6 branch, this is fixed, thanks to Spencer. And in the 2.0 branch, it's fixed as well. So we just want to kind of own up to all of our mistakes. And we apologize very much for not being more careful. And we're happy that people were responsibly disclosing everything to us. So we've had a lot of questions about this or comments about this where people will say, Empires like PowerShell interpreter, some interpreter replacement. We absolutely do not think that. So again, our goal was almost started kind of like a proof of concept to weaponize a lot of existing PowerShell tech. But we are really big believers in offense and depth, so we use a variety of tool sets. Even though we're heavy PowerShell focused, we don't put all of our eggs in one basket to where we don't want all tool sets to fail in case somebody has like really rigid AMSI and like Windows 10 or whatever else. So Empire has a couple thousand hours of dev time behind it, probably, between different combined parties. Meterpreter Metasploit has hundreds of thousands of hours behind it. Like, Empire is never going to be Meterpreter, is never going to be Metasploit. Now, we do believe that it has an advantage in the field, and because it's a scripting language, it's much easier for most people to develop modules and like modify different components in the field on the fly when you're on ops. Like, I know some people that can modify Meterpreter and recompile everything and do whatever, kind of whatever they want. Those are a lot fewer than people that can just modify a scripting language. So to us, it's a tool in the arsenal. We do use it. We also use a variety of other tool sets, but we do like its adaptability in the field. And we'll, tomorrow when I'm talking with Sean Metcalf, I'll show kind of a semi kind of case study example of, adapting stuff in the field and building a module kind of on the fly. So all the demos tomorrow at 10 a.m. for the Anatomy of a Corporate Hack will use Empire kind of operationally, while this talk focuses more on kind of the inner workings and new developments. So we care a lot about crypto. A lot of open source tools will just use self-signed certs. They'll just use RC4 with an embedded key. I know enough about crypto to be dangerous, but I've had, and probably mess everything terribly up, but I've had a lot of people review the specs and like kind of comment on the scheme and everything. So we use something called a Cryptic Key Exchange, where essentially it marries symmetric and asymmetric crypto with RSA and AES, or in the Python agent, it's still terrible. It's like coming back up. And on the Python side, it uses Diffie-Hellman and Cryptic Key Exchange along with AES. So essentially, there's a pre-shared staging key that is used to exchange a key negotiation stager, so a snippet of code that'll generate like a random asymmetric key that then is used to negotiate an additional like session key. So the end result is you get, assuming our implementation is correct, which I believe it is, you get perfect forward secrecy to where even if people do full PCAPs of the entire traffic negotiation, they can't recover the individual session key that's actually used to encrypt traffic. And also, each agent in the entire mesh has a different AES session key. So even if people dump the memory of one of the agents and pulls the key out, they only get the crypto and only get the traffic negotiations for that one agent, instead of saying using an RC4 key for everything. You pull one agent, you get it, and you can decrypt all the malware communications in the entire mesh. So that was essentially kind of the reason behind it for us. We also have process injection that we released a year and a half ago. This is heavily based on Lee's work. So we have a script that's invoked PS inject that uses right now invoke reflected PE injection from Powersploit. We're going to adapt it to use invoked shellcode, so it'll be a lot simpler. And it'll inject a reflective DLL into your process of choice. This does a lot of magic in the back end that I kind of understand but don't completely understand, so you have questions, ask Lee. And it loads up the common language runtime for .NET into the unmanaged, or like C, C++ process, so non.NET process. It loads up .NET, and that non.NET process then loads an assembly that lets you run PowerShell commands. So the end result is, with a PowerShell script, we can inject a whole bunch of stuff into another process and have it launch up our new Empire stager for process migration. Now again, we don't have, or process injection, we don't have like proper process migration, kind of how an interpreter does it. They do some kind of black magic under the hood to transfer the sessions. So we went with a little bit of the easier route to at least allow injection, which we'll show in some of the demos, hopefully. So we had the screenshot last year, we just like it. To us, this was kind of the missing piece that kept it from just being a toy language, to where you can run your PowerShell malware without having PowerShell.exe running. Because PowerShell.exe, our PowerShell is not PowerShell.exe. It is the system.management.automation DLL that you can load up in these .NET assemblies that we use when we inject. So right here in the screenshot, you see PowerShell or Empire running in LSASS, which we wouldn't really recommend, but it was really, really funny to us when we first got this working. Justin and I were like, all right, we have to inject into LSASS, and then it worked, and an agent came back, and we like ran around the office high-fiving, and everyone called us a bunch of nerds, and like we have no idea what's going on. But we were really excited just to show that you can inject and to even up. Like, there's no reason LSASS should be hosting up like .NET stuff or whatever else. So again, kind of the missing piece for us.
Yep, so some of the new features since the initial release, the modules have doubled, which is outrageous in my mind. We've added a lot of stuff. We've tried to keep up with some of the recent research going out. So we've added, some of the Tater stuff, Envy, all that good stuff. Everybody's done really well of not just releasing code and saying, hey, you should throw this in Empire. They've done a great job of, hey, I've wrote this awesome tool. Here's a pull request with the modules. Just test it. I've tested it. Oh, it works. We'll merge it in, and everybody's happy. So community edition's amazing.
Like, I believe it's Kevin Robertson from the Envy author. He's done a really good job. Oh, over there. Thank you for, he's really good. Sorry we didn't land your... Again, we know you have an open pull request, but he's done a great job about syncing all the new versions and everything, and he looked at us when we were trying to hack stuff together to get it working for Empire in the first place, and took that approach and ran with it. And he's like, people like him, Kevin, have done an awesome job about like updating and contributing their kind of PowerShell-based attack tools and syncing them with the framework. So thanks again.
Yep, so the community, I guess, how they interact with us is amazing in the sense that we get code submitted to us. We don't have to spend our time sitting down and writing these modules on all these cool, new techniques that come out. People are interested in getting their code into the framework, which is awesome. Out of the RedServe 32 payload, shout out to Casey Smith. I don't know, I'm sure he's in here somewhere, sitting in front row. Amazing technique that he discovered. So that got added pretty quickly. All the good stuff. Most important, there were new Trollsploit modules added. So good for that. Key Thief, which Will and Lee Christensen did some awesome work on recovering some password data memory if you're using KeyPass. If you haven't checked that out, I would definitely recommend it. Uac Bypasses. We'll go over that later. And then lots more. So we'll kind of cover some of the top ones here in a bit. One of the bigger additions in my mind that really pushed things forward was the addition to there's a Restful API interface. And so you can write things to integrate into Empire via the API. And if you have anything that you want to add since you wrote that.
Yeah, I just want to thank Carlos for kind of helping me design it. He spent a full week kind of going back and forth with me, like with the design decisions, and a lot of these things are really kind of built with the Restful API. We're built in kind of coordination with Carlos. So again, awesome help, awesome participation, and we're really excited for kind of the integrations that the Restful API will hopefully introduce into the future. We already had some like, web interfaces and things like that. So we're excited about it because it abstracts away the complexity of interacting with the framework.
Makes it nice and easy for people to integrate the framework itself into other tool sets. So Python Empire, initially released at it was Hack Miami, and then they presented on it this year at B-Sides LV out in Vegas. It's an awesome framework. It was actually Will rage coded like a good portion of it over Christmas break due to the fact that we didn't have Tradecraft for OS X, and we got into an environment where like, well, poop. We don't have anything to use it for. So it's awesome. It works on Linux OS X. It was integrated, or it was created as a separate project, and so one of the issues was it was maintained as a separate code base, which we'll kind of cover some of the oopsies over that later. So some of the drawbacks of the Empire: we've never built a wrap before. We're three dudes. Mistakes were made, lessons were learned. The learning process was awesome. So there's no better way to learn the process and actually going through it. The only comms methods that existed when it was initially released were HTTP and HTTPS, and we'll kind of go over some of the expansion of that here in a little bit. Like I mentioned, the separate code bases made maintaining them a really big pain in the butt. And so if there was a vuln, for example, RCE, and PowerShell Empire, we had to actually go and patch the other framework as well. And so we were doubling the work that we had to do.
And also, we know the naming schemes. We thought we were being clever, but when people would say Empire, like, in conversations, we didn't know what they were talking about, so we had a lot of people just give a shit for whatever the naming scheme is. But anyways, that will be fixed with the new release, which we're excited about.
And then 2.0, which is awesome. So some of the motivations for combining the two frameworks. 2.0 is a combination of both PowerShell Empire and Python Empire. That way, everything's maintained in one centralized location, and there's really easy usability between the two agents. You're not always, on an assessment, you're not only going to run into only Windows boxes or only OS X boxes. So having them integrated into one framework makes it easy, so you don't have to stand up another server with Python Empire running on it if you want to go and hop over to sections that contain OS X or Linux boxes. One of the other motivations was to modulize the C2, and so C2 was pretty static in the sense that we only had, HTTP and HTTPS initially. This is going to allow us, 2.0 is going to allow us to expand the actual C2 components pretty dramatically, which I think a lot of people, once they see how to write modules itself for C2, is going to make it really awesome to see what kind of stuff people write, evil stuff. And then we got to remove some of the code rot, and so we had some old code. We've never written a wrap before, and so we cleaned it up, learned from kind of the mistakes that we made and the suggestions we got from the community, and kind of trimmed it down and made it nice and pretty.
So there was a lot of design decisions made. Like Matt said, I like to rage code a lot. Like my team likes to say, I'm pretty much fueled by caffeine, alcohol, and rage whenever I code. So there's a lot of late night caffeine fueled coding sessions. So a lot of the architectural decisions that were made, you know, a year and a half or almost 2 years ago when the project originally started, we realized weren't conducive to expanding a lot of the new features we wanted to implement. So one of the biggest things that was a giant pain is like redesigning things like the packet structure, which I'll go over here in a second. You know, how the agents interact with the listeners. We went back and forth of saying, okay, if we want the projects combined, how do we, for example, if a launcher comes in and requests a first stage, it requests like kind of the key negotiation stager, and you want to have Python and PowerShell, how do you differentiate and say, I should return Python code or I should return PowerShell code? Do I differentiate it by the port? Do I embed some kind of metadata? Like there's a lot of these weird kind of design decisions that don't necessarily have a right or wrong answer. So if you guys think the approach we took is terrible, like please tell us, and ideally tell us a better way to do it. So the big design decision that was revamped was all of the kind of agent data packets are wrapped in what we're calling kind of like a routing or a metadata packet. And the motivation behind this is we eventually want to do peer-to-peer C2. So if we have something like SMB, or if we have something like the Active Directory C2, or different components to where it might be hard for the server to differentiate what the actual agent session ID is, what the language is. You can't just pull stuff out of a cookie every single time like you could with HTTP. So there's kind of a wrapped packet that has a couple bits of metadata, the language and different things we'll go over, and every single agent in the mesh, or you know, kind of linked to that controller, can decrypt just that routing metadata for every other agent. Now that doesn't give away any kind of secret information or staging, or you know, like kind of client communication components or key stuff, but it allows you to decrypt just enough to figure out, should I route this packet to somebody else, or should I decrypt it myself and return the results? So the routing packet is encrypted with the initial staging key that was static and shared with the server. And then each agent still has its own negotiated session key. So each agent in your entire C2 mesh cannot decrypt the actual data and communications results from anybody else, but they can figure out, do I need to send this to another agent? So, you know, it's probably kind of hard to see, but the general packet up top, we have the routing data that has an IV, so it's going to change every single time. It's encrypted with RC4 with kind of that pre-established static staging key. That packet is only going to be 16 bytes, so it has the session ID for 8 bytes, the language, so we have 1 byte, and so we can handle up to 32 different languages, a meta field, which will say if it's like staging component, stage 1, stage 2, those types of things, 2 bytes for extra expansion, so we try not to constrain ourselves like we did before, and then kind of the length component. Then the rest of the AES encrypted client packet. What's nice with these is these are kind of stackable, so you can just put them like, you know, one on top of another, and each routing kind of metadata packet can contain an arbitrary number of client packets embedded within it. So the client packets, which are also stackable for multiple taskings for a particular agent, these have been trimmed down and kind of optimized. I had a lot of help from a lot of people, especially John Kay from MWR out in the UK. He looked over the spec. I was in London for 44Con last week and had some beers with him, and he very like awesomely just like gave me some really, really good feedback. He's super smart with crypto, so he's able to give me some good information about how to make sure this was designed correctly. So we trimmed down the HMAC a little bit. We kept it kind of the specific RSC compliant as far as keeping everything authenticated. And we trimmed down kind of, I'm not going to go over every single field because you guys probably don't care. But we also, with the expansion of this, we want to enable people to have tasks that span multiple packets. So if you're doing something like DNS or a channel that's a lot smaller, it's not quite as fat as HTTP or arbitrary size, we want to be able to kind of have a basic like packet number, packet length, and be able to recombine a lot of these packets in the stream. So again, end result is probably boring to a lot of people, but we spent a huge amount of work trying to lay the groundwork to expand like really cool future capabilities. We have a few cool things to show today when we drop stuff, and we're really kind of hoping to inspire people to see what's actually possible and have more people contribute. So, new stuff, a few more new features. The HTTP listener is being redone with Flask. A lot of people had issues with too many agents with the simple HTTP listener, and it'll kind of crap out and die. We haven't done scale testing yet. Again, it's a beta, but hopefully that'll be resolved. We removed the epoch syncing. The intention was for anti-replay components, but we had so many issues with people that were just having like time zone syncing, whatever kind of stuff. So we removed that at the expense of having some anti-replay protection removed, but We felt it was just, again, kind of a decision we decided to make. All this staging now in PowerShell uses HMAC. It's all authenticated, can't be tampered with. We use RC4 instead of XOR, so that staging will change every single time with an IV. And we put in Matt's AMSI bypass into the PowerShell stager right when everything launches to try to turn off the bit for AMSI detection for kind of new Windows systems. We also have orphaned agent renegotiation. So if your server dies, your database is corrupted, whatever else, if you start a server up at the same place with the same password, like the same kind of server initial server password, the agent will detect if it's not checked in, the server will return a specific response, and the agent will restage. So it does involve some more communication, but you won't just have the pure orphaned agents without a way to recover them. We also have, I know it's not the best name, but like external modules, but modules that don't rely on a session ID. So we have a way to generate a pre-staged agent. You get the code, and then it pre-registers it in the database, and you can just run the code and then execute whatever you want. Our idea with this going forward would be for something like DNS, like kind of a channel that's really, really thin. If you want to deliver the entire agent in your initial phishing payload, and you don't want to like go through the entire staging process. So again, trying to think ahead. We have an awesome new improved Kerberos module. This was a Machosec, I think, submitted a pull request to PowerView a few weeks ago. So previously, if you wanted to do Kerber roasting, which I'll go over in an operational demo actually tomorrow with Sean, you would have to request all the tickets with some one-liners and run Mimikatz and extract everything out, all the tickets out to disk or whatever else. And like we all know, Mimikatz is awesome. It's also public enemy #1 for defenders. So once defenses start kicking in, this is what like one of the top things they're trying to catch, right? So if there's any way to execute actions without having to inject all this code and run Mimikatz and play with stuff with LSASS, we'd prefer that. So really simple, like just like a dozen or so lines of PowerShell. You can request the ticket, pull out just the encrypted part, and then transform it into a format that is readily crackable for John. So you run Kerberos, or you run this get spin tickets. You can specify a username or just all spin tickets you can find. And it dumps out this hash, then you can run with the new updated John to just crack the TGS or Hashcat. So pretty awesome. We just put this in about a week ago, and we got to use it, I think, on OneUp, and it's way nicer, way simpler than it used to be. We also have a Bloodhound module. So it'll execute the Bloodhound ingester, it does the ingestion, gets all the CSVs, which then you can download, and then download, pull back, and throw into your Bloodhound analysis platform. So we've done a huge amount of work with the ingester and with Bloodhound. We know there's a long ways to go as far as the ingester goes. There's scaling issues, memory issues, and all that we're trying to address. But it's at least weaponized in some form in Empire. It will work in smaller environments. In larger environments, you still might have a few issues, but again, it doesn't have the REST API ingestion kind of component, but it'll at least execute it and get the CSVs you can download.
Yep, so on top of all that awesome stuff, we added in a few new UAC bypasses. So from an operational perspective, we run into this quite a lot. Organizations haven't quite nailed down the whole don't run as local admin concept for some reason. So it's still a pretty important thing to have around. This new one that I actually discovered a few weeks ago is it's fileless, and so you just take advantage of registry hijacking to start our process, aka PowerShell is a high integrity process.
It's one of the first ones that doesn't drop a DLL to disk, so it's going to be a lot harder to catch, or you're not having to worry about dropping a malicious binary DLL to disk every time that AV might snarf up.
Yep, so typically a lot of the public UAC bypasses that are out right now take advantage of the iFile operation COM object to perform a privileged file copy into a protected location and then exploit a DLL hijack to load that DLL up and execute whatever arbitrary code may be in that DLL. So this takes advantage of doing the same process without having to do a privileged file copy or drop a DLL down. Cool. So Empire integration, the Python side. So this is what the new menu looks like. As you can see, there are 249 modules now. This is due to the expansion in addition of the two. Okay, so Empire integration, that is where the new repo is at. GitHub.com, adaptive threat, Empire. The merged codebase will be as a branch, and so it's not ready to be merged into master yet.
We're going to do a lot of testing, and after it's finally ready to merge to master, we'll overwrite the existing project. The Python Empire code will be left up for a few months. It will change the README to deprecated, and eventually about a year or so from now, we'll remove the code off again.
And we're taking in the developers that worked on the Python Empire portion, and we're all merging into one project. So now we will have an actual 5-person quote-unquote full-time AKA in our very limited free-time dev team, which will help instead of having 2 of us. So hopefully you guys see a little more of a response for issues and pull requests. So this is what the menu looks like as far as typical usage, starting up a listener. And as you can see here, you can start a launcher for Python, and then right after that start a launcher for PowerShell. They both use the same listener. So as Will mentioned, there's some stuff in the packet that's able to identify what language the target host is coming in. Yep. And yeah, so it'll list as under the language column which actual language the agent's running under. And the modules are broken out per language, and so only Python or Linux, the OSX PostX modules will be available in the Python agent, and the PowerShell PostX modules will be available.
So when you interact with each agent, it drops into the language aware menu, or the language specific menu, and when you tab complete all the modules to use, it only tab completes for the one appropriate for your language and architecture.
Yep.
So we try to keep the UI as seamless as possible for people coming from the previous project.
Yep. So interface integration, it's relatively the same. Interact with the agent name, and you'll just drop into the agent menu. The commands in the agent itself is language dependent, and so there are, PS isn't exactly going to match exactly what it does in the Python version, but help is awesome. If you just type help, it'll tell you everything you can do. Use module, same thing for both agents. Everything's tab completable, so that'll get you where you need to go. And then we added a lot more stagers. So there are stagers for both languages. Those are also tab completable, so if you just hit tab twice, it'll dump everything for you. A lot of really awesome stuff there. That's if there's gonna be one thing you're gonna look at initially, I would recommend checking the stagers out.
All right, the really cool stuff, the modular C2, or modularized C2. So previously, the listeners were hard to integrate into the code base. So if you wanted to do something like, I want DNS, it would have been extremely, extremely difficult to try to implement all those transports and implement all the communications. Now, the listeners are encapsulated in self-contained modules. You can also drag and drop these. So if you have a private C2 module, one of which we'll demonstrate, you can just take that code and just drag and drop it right into your Empire folder when it starts up. You load up, and you have like a brand new listener transport that you can use. We'll go over kind of the structure of how this will work. For listener modules, at least 2 functions are required. You need the generate comms function, which will generate just the communications functions that are passed into the agent. So like, send packet or get task, like send response, that type of thing. So we'll go over like why this is pretty cool, I think, here in a little bit. And a start. So if you actually have to have a server component, you need a start function, which will start the server side. Oh, and the listeners are responsible for language support. So, Python or PowerShell or whatever. So if you want staging supported, so say for DNS, the first DNS module you write will probably only support communications and not staging, but we'll go over how you can kind of integrate those. So you need like something that generates the launcher, the little one-liner launcher, something that generates the key negotiation stager, and something that generates the agent. So nothing too crazy. For listeners HTTP, like we mentioned, the original HTTP was redone with Flask, so that routing packet is base 64 and stuffed into a cookie value, which is kind of how it's deconflicted on the server side. This module will generate the Python and PowerShell launcher staging code, like the whole complete package. And if you would like to modify kind of the communications as far as like kind of changing up the communication profile, how it looks on the wire, it's pretty easy to go in there and say like, I want a different cookie value. I want to not base 64 this. I want to stuff it into a different field, a different header. I want to pin binary data or something like that to the post. Like, there's a lot of things you can modify.
And then this is one of my favorite listeners. So there's an Internet Explorer.
This one's being released. So.
An Internet Explorer hidden COM object, and so the listener itself will communicate over iexplorer.exe as a hidden COM object, which is initiated through PowerShell. So it's fully proxy aware, all that good stuff. One of my favorites. I use every time I test, I just default to that because it's amazing, and it's kind of a good example of being able to drag and drop or integrate your own techniques that you may think of as far as initiating comms. And then there's also the HTTP foreign listener, which is super awesome. And basically, it's just allowed for passing. So if you've got 2 Empire servers, we don't have where 2 people can connect to the same server and just interact with agents simultaneously. If you have two servers and you share the negotiation key, you can actually just pass agents between two, which makes it nice for servers that are classified for doing different things like phishing versus PostX versus long haul stuff like that.
We also completely redid kind of the hop listener, so the hop PHP pivot. You can drop this little PHP file on whatever server you want. It's a lot more stable. It should be a lot more stable. I'm sorry, I should say. We had a lot of people report issues with it in the past, but hopefully this will allow you to build more complex infrastructure. Dropping these PHP files, having your agents connect to them, and kind of connect back to the control server. We're definitely looking for more language-based redirectors, so if anyone wants to write ASP, JSP, whatever else type of the more that we have, kind of the better. Again, right now, all we use PHP. I'm not a web dev. It took me a lot longer than it should have to write, 40 lines of PHP. And then I remembered why I like Python and PowerShell so much. But anyways, go ahead.
There's also a interpreter listener, so it allows you to easily pass agents, to interpreter, Cobalt Strike, or whatever. The transport methods are the same, and so it just on the back end it takes advantage of PowerSploit's the old invoke shellcode. It doesn't anymore for reasons. But the one that we use actually integrates so that it actually can run interpreter shellcode pretty easily and makes it for spawning over to the other frameworks pretty seamless.
Cool. So this is the most exciting to me. So the new packet structure, one of the motivations behind it was to allow you to be able to build modules that would operate over third-party sites, third-party trusted sites. So think Dropbox, think private gist, think OneDrive, kind of think any of these third-party trusted sites that are very likely going to be allowed out as far as the egress goes with organizations. But up until this point, there wasn't an easy way to get a full agent with full communications and the full PostX capability of Empire. And this is kind of where we realized the power of a framework in that we just had to figure out this one transport part, and then we got all the post-exploitation components for free. We didn't have to build a POC or, it's kind of a separate tool that would operate over these new transports. So let your imagination run with it. Also, totally don't break any terms of service. We're not lawyers. Please don't sue me. And Dropbox, please don't hate me. But we totally have a Dropbox POC, which we're going to show you guys. Here's the deal with the third-party transports. At this point, we are not going to publicly release the Dropbox or similar type of third-party C2 transports. We are going to build a template that would show you how to theoretically interact with third-party sites. We are going to maybe write a blog post that would theoretically talk about how you would theoretically design a module of this type. But we care a lot about the ethics of offense. We care a lot about red versus blue. I know Carlos's talk was awesome about purple teaming. And to us, the line was kind of drawn in that we have a pretty reasonably robust kind of functional post-exploitation toolkit, something that would let anyone download it and then run it through third-party Dropbox sites in a way that probably won't be detected from most blue teams was just slightly over the line for us at this point. We're not saying we won't release it at some point in the future, but for now, it's staying with us, and if anyone submits pull requests for third-party modules, we may or may not accept them, maybe leaning more towards not. So write them yourself. We'll try to show you proof of concept how, but you're going to have to kind of put a little bit of work in. Well, the coolest part with this is you can hot switch your listeners. So if you have different transports, with that little generate comms methods, the old generate comm method, it'll generate just the snippet of code that can be dynamically EXed or evaled or whatever for Python, and you can update the transports on the fly, and you can do this in mass. So if you had all your agents running over HTTP, you could switch all of them to start running over Dropbox, and they'll all just switch simultaneously. Or you could have certain ones switch from Dropbox to OneDrive to IECOM objects to DNS or whatever transports you have. So there's a management switch listener module which makes this really easy, and we'll kind of demo. And just real quick, I'll do this. In the next few months, we would really like SMB. We don't know if there's a couple POCs from a few people out there that we're going to try to draw from. Matt's starting to work on DNS, laying the groundwork. We know that's a big missing protocol for us. That's a biggie. And I don't know if I'm sure people don't have to shout it out, but if you guys have any other ideas for interesting transports that fit within kind of the architecture that we described, we would love to hear it. Write some new transport, ICMP or, whatever else. Maybe at some point we might try to do the Active Directory C2 component through property sets, things like that. All right. Now we're going to try to show demos. Can you? That's a site. That over there? Oh, wait, I need to. There we go. Okay. And now I actually can. Okay, so right here, when we started Empire, we already have some listeners built. We have HTTP, IACOM, and Dropbox. You see the file syncing. Now we're going to start our launcher. What this is doing in the back end is it actually has a full interval, so the server is going to the Restful API for Dropbox, and that's just doing kind of communication. There's no packets are being sent directly to the client from the full server. Here, it's sped up quickly. The agent is going to retrieve like the staging log from the Dropbox folder. It's going to upload the stage 1, and it's basically doing an entire key exchange over the Restful API to Dropbox. Now we have our complete staged, fully staged over Dropbox agent with Empire. We can pass anything we want. We're going to get the system code and do a UMI to prove that we actually have code execution over Dropbox. You see here again, it's saying it's like uploading it to this kind of Dropbox folder stuff in the back end. Now we're going to switch the listener to HTTP to show the dynamic update. So when that agent comes in, it's going to grab or it's going to go up to Dropbox, download the binary log, it's all encrypted, like the same kind of encryption. It's going to update it, switch over to the HTTP listener we had, and we prove right here that it is switched to the HTTP passing format on the fly. And again, you could do this with all of your agents. It doesn't just have to be one of them. Was that cool? Did people? I thought it was really cool. I was like, clap! Come on. And one more. I think we're just gonna have to. This is what hurt. Should be tough. All right, Tim. Okay, so this is going to demonstrate the multiple languages. I'm sorry, I don't have the Zoom on this one. I forgot to put it in. We recorded this like an hour ago. We're freaking out. So we have one listener built right here, talking on one port. We're going to generate. Just show the generation for that Powershell launcher. Show the generation for the Python launcher. And actually already has agents staging, or already has agents staged before the server started up with the common demonstration. So we have one for Windows, we have one for Mac, and we have one for Linux. So PowerShell, Python, and Python. We're interacting with the PowerShell agent. You see all the if and deck and all the language appropriate menus. We're going to run on full exploit. We're going to display some message text. So just showing you use modules, have complete, is the going to have complete the old PowerShell Empire module. Execute it, kind of swap over to the same job started in job architecture. See, okay, that's kind of Linux VM. I don't have OS X VM, so the next one is actually going to run on my actual OS X one, so we'll see how we're recording the stream flow stuff that I have. But I'm going to show one of our favorite modules, which is a prompt module that's based off of Fuzzy Mouse work here, I think 2 or 3 years ago, with connecting back and forth slide ever. So it actually prompts up a binary that you can specify by default password, and it prompts a fake-looking password dialog that people, whenever they type, require your password to continue. You press enter and flip it back, and it'll return whatever the actual text. So we really kind of like that for phishing. And then we have like a, that was really awkward, like a sudo spawn kind of thing. Yep. All right. Yeah, too many Smirnoff ices. Okay, so we're going to see if this actually works. It's either going to be kind of cool or a really awesome idea, or a really terrible idea. So, crap, you guys can't see that. Once I can get, oh crap. Oh, I don't have the Wi-Fi on. Damn it. Anyways, all right. Yeah, I turned it off. If anyone has any questions while I'm doing this, before I try to push all the code, any questions, we can try to answer them while this is starting up. No questions? All right, that's really terrible. I'm sorry. We're going to go push the code in like 5 minutes right when we get off the stage. So it'll be in a branch called 2.0_beta on the new adaptive threat /Empire location. So thank you guys so much. This has been awesome.